All right. Hey, thanks for bearing with us there. We had a couple of bumps in the road, cross between a couple of different versions of our program that we deliver here, different ways that we bring the stream together between the recorded content um, that speakers are putting together in advance and the live content, such as what you're seeing right here. So thanks Scott, Sasha and Leo and everybody behind the stages gluing it all together. And we're back here now, and I'm speaking with Robin, who is ready to take on some of your questions and address some of the comments over here on the Etherpad. If you want to jump in there, there's links in the chat. And thanks so much, Robin, for your talk. And it's also been a pleasure chatting with you just a little bit over the last couple of months on IRC.
Yeah, absolutely. Great meeting you. All right, everyone. I think I am streaming now. So let's look at. Let's see. I see the IRC scrolling. So let's see where that's going. Yes, the Common Lisp is what I thought would piss people off, and because it's not part of either community, but I think it would be a good compromise for building Elisp into a language that's more suitable for building large systems like the kind that we are building in Emacs today. I also left out an important part of the talk, which is part of the motivation for transitioning from C to Lisp, and that's the performance characteristics fundamentally change when you get a modern and high performance Lisp system involved. It starts getting less practical to just call out to C to speed up every operation. Among other things, you lose the ability to use more advanced control structures like delimited continuations. And you also have to pay the overhead of calling out to a foreign function. So it gets to be an increasingly better deal to optimize your Lisp implementation and provide ways for building faster Lisp programs, such as type annotations, once you've gotten over a certain threshold of performance. I'm going to look at the pad. Oh, here we go. The first question is about fibers and whether they help with making Elisp concurrent in terms of its data structures. Yes, that's absolutely correct. Fibers by themselves do not provide thread safety for any of the existing Emacs data structures. What they are useful for is building things that don't use Emacs data structures, say a network client that reads input from a stream, or in Scheme, a port, or in Lisp, a stream instead of a buffer. And we can also take a look at options for making more Emacs features concurrency safe or thread safe. For example, we could introduce the idea of a thread local buffer that didn't require locks for sharing between different threads. And I'm not sure how that would develop, but I'm sure the Emacs maintainers already have some ideas in this direction. And Fibers will basically provide a high performance system that you can use apart from ordinary Emacs Lisp constructs. Let's see, we have another question. Emacs is roughly 25% C. How much of Guile is in C? Well, part of my point about C is not so much that well, obviously I phrased it a little provocatively, but the problem is not so much that there is C, but that there is so much C involved at every single layer of the application. So for example, we're limited in our ability to use tools like limited continuations, which can be used to express buffer local variable binding in a few dozen lines, because Emacs has so much calling back and forth between Guile and C, due to so much basic functionality being in primitive C subroutines. So that's one issue, apart from the question of how much is in a particular language. To answer the question about Guile, Guile has about 165,000 lines of scheme code and about 160,000 lines of C code, so it's about half and half. And that shouldn't really be surprising, given that it is actually focused on low-level things like building a high-performance bytecode compiler and a just-in-time compiler and so on, as well as providing its own fairly rich but still far less complete than Emacs's standard library in terms of ICE9 and other system libraries shipped with Guile. The next question is on a Common Lisp implementation for Guile and whether work on it is underway. In fact, work on it is already underway. I've been working on it on and off in my spare time for a couple of years now. I've gotten, I think, a couple of chapters of the hyperspec done, if you want to measure it that way. But I've been focusing my work more on research and on what we need to do to have a Lisp environment, a polyglot Lisp environment, wherein the features of Common Lisp and Scheme and Emacs Lisp can all work easily and ergonomically together. So this involves things like the question of Lisps having Lisp 1s versus Lisp 2s. That is, a Lisp 1-like scheme has one namespace, like every variable is a single name that can refer to one value, whereas in Lisp 2s, like Emacs Lisp, symbols can have different definitions as functions and as variables, as well as other namespaces like property lists. So Kent Pittman has some interesting thoughts on this that I've been looking into. Another issue is the interaction between package and module systems. So I don't have really anything ready to publish just yet on this, but I have been looking into the background issues of integrating this into Guile in a useful way. Let's see, there's one other thing I was going to mention. Okay, I've lost it, but yeah, there is some work already, and if people are interested in moving Emacs in this direction, then we'll certainly start working on it in earnest. Another question, did switching from Guile 2 to 3 give any performance benefits? Well, honestly, we're not really benchmarking stuff here because Guile-Emacs has so much overhead, from structuring the compiler to closely conform to Emacs in terms of like even things as simple as metadata layout for variable information. So I haven't actually noticed a perceptible change. I would guess, based on the Gabriel benchmark results, that it has benefited from somewhat from Guile 3's performance improvements. But for Emacs, I just don't know yet. And working on the compiler's code generation and lowering the overhead is going to be the thing that provides the most return for improving that aspect of Guile-Emacs. Let's see, I see SICL mentioned here, as well as SBCL. And it could certainly help with the implementation of Common Lisp and Guile, because a lot of the basic stuff is just providing a new interface to some bit of functionality. Like the sequence library, it's mostly stuff that we already have through SRFIs and so on. The difficult, well, not the difficult, but the time-consuming parts are going to be all the little DSLs that Common Lisp has packed up inside it, like pretty printing, format, loop, and so on. And it's for those high-level features that I think we could potentially share code with other Common Lisp implementations. And Common Lisp implementations do tend to be permissively licensed. SBCL is public domain, for example, so there's no barrier to sharing code with them. There's another question about whether the Emacs maintainers are interested in switching to Guile as the engine for Emacs Lisp. I can't speak for the current maintainers. I can say that people have talked to previous Emacs maintainers about the whole idea, and their attitude was generally cautiously optimistic, as in it's not something it's somewhat political. They didn't want to get into it, but they didn't think that it was a bad idea, and they wanted to know more about how it might evolve in the future. I can comment that Eli Zaretsky, who I believe is the current Emacs maintainer, is very concerned about cross-platform compatibility. And so if I can guess at his priorities correctly, I think that that's something that we'll have to make sure is rock solid before we propose any kind of upstreaming of Guile-Emacs. But in general, maintainers have been cautious but curious.
So I just wanted to break in to note at this point that as a live, I couldn't do so more gracefully while we were still on stream, but I wanted to let you know that just as of 10 seconds ago or so, we've had to cut away into our next talk, but we can keep going here as long as we like.
Okay. Let's wrap up. There's only a couple questions left on the pad, so I'll answer those, and then I'll be available on IRC. So the next question is whether Guile-Emacs will be able to collaborate with projects like Gypsum and the native compilation projects, or the pre-scheme efforts. That is, oh yes, that is one of the things I forgot to bring up in my talk. So first of all, Gypsum is approaching a similar idea from a different direction. And we clearly have a different focus. My focus is on improving Emacs Lisp and making Emacs itself better by integrating Guile Elisp and Emacs, rather than replacing Elisp or deprecating it in any way. But given Gypsum's requirements, I do think that we could share a lot of code required for emulating basic Emacs functionality. And this could even become interesting if we get to the point of rewriting parts of Emacs in Lisp. With respect to the native compilation effort, I'm familiar with it. I'm not that impressed with the results of it. It's a very impressive effort, but as far as I can tell, it's accelerating a bytecode interpreter that is just simply has an out-of-date design, to be quite blunt. It's possible that Emacs's JIT has ideas that Guile should adopt, like perhaps libgcc JIT might perhaps be better than GNU Lightning, which is a relatively simple JIT that Guile uses. But it doesn't have to have a direct relationship to Guile-Emacs. And as far as pre-scheme goes, I have been watching Flat Watson's work on pre-scheme with great interest, because Scheme 48 used to be my favorite implementation. And I do think that it could be, it's a tool that we should look at when we're thinking about moving functionality into Lisp, and could certainly make it easier to upstream some of the work we may end up doing. All right, do we have more questions? There's a question about SICL and SBCL. I think I answered that earlier. It should help us implement Common Lisp. And when it comes to high-level features and the various large subcomponents of Common Lisp. Now, another important factor is that Guile already has decent support for the Common Lisp object system. Without that, it would be far more difficult. But I do expect that we can share code with other Common Lisp implementations. I've personally rated Common Lisp compiler code when working on Guile-Hoot, for example. So there are definitely places where they can contribute. Regarding the Hoot project and its relationship to Guile-Emacs, it's a purely speculative thing. First of all, Hoot is only tested on Scheme to WebAssembly compilations. I've heard some suggestions that some uses of Trio may not be compatible with the Hoot compiler. I'm not sure if that's the case or not. But it is a complete enough project that if Emacs is, say, 90% Lisp, there's only a few thousand lines of C code to implement, then it would be entirely practical to compile Emacs WebAssembly, as long as we had a backend, like one based on the browser's document object model, or some sort of graphical interface through WASI. And that may have some interesting applications for portability to unusual platforms. It may even bring performance advantages in cases where the WebAssembly implementation is connected to a tracing just-in-time compiler, because that may be more appropriate to the high level of dynamism that Emacs Lisp has than the kind of simple template JITs that both Emacs and Guile are using. So it would definitely be an interesting.
What a fascinating point. Just to break into active listen a little, so this doesn't to you feel like you talking to yourself. I can see from chat and the questions still coming in, comments. It isn't, but I just want you to be able to hear and feel that. Yeah, great point there.
All right, thank you. And yes, if there are more questions, keep throwing them at me.
I should probably also mention I will have to jump out myself, but the recording will automatically end when we all jump out, or just drop a note anywhere, ping me, whatever. And I'll come along and shut off the recording, and we'll trim it up before we publish it. I'm looking forward to reading through anything I do miss. Thank you.
Sounds good. All right, I'm not seeing changes in the Etherpad, so I'm going to close this in maybe 30 seconds if there are no more additions. Thanks everyone for the interesting and very very pointed questions on some of the most significant areas. I appreciate everyone's feedback, and I'm glad this provoked so much curiosity in people. Thank you, Yannicka. All right, I think we are done with the Q&A session, so I'm going to close this BBB, and we can continue with the rest of EmacsConf.
You are currently the only person in this conference.